Okay, in this third session, we have three speakers, very respective speakers. First speaker is Ali Sangster, and second David Hicks and Chung. So I would like to invite Ali Sangster to present her presentation.
Everyone, my name is David Hicks. I am Senior Vice President of Upstream at IHS Markit. With me is Ali Sangster, who is our Vice President of Analytics for our Energy and Natural Resources Group, which extends a little bit larger than the upstream space itself. And just as a little background on IHS Markit, we are quite a large multi-dimensional company, information company, and analytics company, sort of three main divisions: finance, transportation, and energy and natural resources. And that is the area in which we're going to talk about today primarily. And it's important to remember, those of you out there who might know IHS from before the merger with Markit might think of us as simply an energy company, energy data company, and primarily in the exploration production space. And we certainly still are a leader in that area. But just as I mentioned, Ali and her role across the much broader energy and natural resources, as many of you will know more and more today, the need to tie upstream exploration, production of hydrocarbons, into midstream, the transportation, downstream, and ultimately into the renewables and clean tech space is all becoming much more of a blur, if you will, and they are becoming much more interconnected. And bringing it back to our presentation, the key here is even within the upstream space, we deal with what we believe is quite a massive amount of data, and providing access to our customers in an easy way, not just to get to the data, but to visualize it, and then of course to analyze it and really pull out the key insights is crucial. But that's upstream alone. And as I just mentioned, as we start to work more and more with refineries, chemicals industry, retail, and again, in the burgeoning renewables and clean tech space, the amount of data is incredible, I guess we would say, and growing every day. So the challenge of managing it, visualizing and analyzing it is a huge need for us, and we're really excited today to talk a little bit about what we're doing with OmniSci, and of course using GPU, and the performance that you get with multiple GPUs is a big part of being able to work with this data like this. So anyway, we'll talk through a number of examples that we're working on here, and it spans quite a wide breadth, if you will. And Ali, I think at this point I might turn it over to you to take us through a couple of those specific examples.
Great, thank you, David. So our overall value proposition, just looking at everything, putting it all together, is, how do we extract more value from IHS data? And then moving towards that interactive, analytics, but also by utilizing a lot of our data science predictive analytics, how do we bring that all together? So, get rid of data reshaping, different types of, limitations for the amount of data, the different types of data, rendering slow to load, just the typical problems that occur today with when you're trying to utilize millions and millions of data points. It's just, it can be a challenge. And then with our predictive analytics and our models, we're really looking for an environment where we can embed the models and then apply them to across multiple data sets in order just to run, anything from risk scenarios, what if scenarios, and then just bringing, like David mentioned earlier, just from a global perspective, how do we bring it all together in an interactive environment so it makes sense and answers questions and solves problems?
Yeah, and Ali, I'll just jump back in and then I won't interrupt anymore, but you raise a good point, and I think that we're going to talk today about some very specific, very data-dense examples, very valuable, very upstream-oriented for the most part, but with all the discussion we have today about data lakes and having access to all this data, as Ali was saying, unless you can extract the value that you want from that massive amount of data. So today, understanding as much about a company's financial position and future compared to the work they're actually doing, let's say it was drilling a well and how much oil and gas they are producing or plan, but tying financials in with that domain data into some perhaps global economic data, you can start to see how broad that is. But if you can't work with it, visualize it in a coherent way, you're not really getting what you want out of it. Okay, Ali, last time.
No, that's perfect. All right, so use case number one, analyzing well variances. So this one is a big deal because, you know, from an operator perspective, or you're buying or selling, or you're trying to just understand, you know, the risk in general. You know, drilling's expensive, right? So it's one of those to where, you know, why are wells overperforming or are they underperforming? And there could be a number of different reasons why that actually is. So by bringing in, you know, acreage, inventory, economics data, you know, using just data, drilling down into any subset, you know, within a well or within a completion, quantifying, well completions, you know, so is it, you know, well versus depth versus, you know, proppant fluid, all of those other, or I should say, all of those variables that impact the production, even not necessarily so much, you know, geology, but then, you know, back to the economics or to the engineering, they all make a difference. So it's, I mean, we're talking about a number of different data points in order to make that analysis, or I guess to make that decision or come to that understanding. So it's important. So the fluidity with all the North American well assets. So you can see here, this is a big one. So this is 492 million records. This is huge for us because, you know, having an environment to get this many wells to perform, it's very powerful. So with OmniSci, with this particular case, we were able to take basins, and you can see the actual well count by basin, the interactive map, and then the historical break-even factors, and then taking it down to wells by their post-peak declines, and then their peak productivity. And so it's, you know, in a traditional browser, you're doing a search by search, and you're kind of slowly getting up to that data. With this environment, you're able to evaluate everything at one time. So this is a national view of operators and reservoirs. Once again, you have, actually this one is probably a couple of 100 million records because it's all the individual data points behind the well as well. So you can see the quality of all the assets. So that was the quality gradient map. You've got the average break even by the top 25 operators by reservoir. So that's, I mean, those are stacked data points as well. Key statistics by producer, and then your average BE, and then your reservoir average BE. So this is, you know, it's easy to see which operators are, or which reservoirs really by operator have the best break evens. And now this one is using all US wells, and this is by total vertical depth, 336 million records. And this was important because of course, you have the geospatial component. So you're mapping the wells by break even, and then with the reservoir and operator metrics. So you can quickly analyze operator KPIs. The operators are ranked by break even, by EUR. And then you have the selection based on quintiles, which, you know, that one is big for our financial customers. Interpret the total vertical depths versus the lateral lengths, the relationships between the two. And then you have the georeference break-evens. You've got your 12-month declines, and then you can characterize it by reservoir and by operator break-even. So then, obviously towards the bottom, there's the whole temporal analysis. So everything through time. So then you can then understand, so you can analyze the frac stages, proppant loading, the fluid volumes. And that's important too, because obviously that, you know, the proppant loading and the fluid volumes, it relates to the well design and then also cost. And then you can assess the trends over time and space. And that's something that's a really big deal, especially when you're moving through time, because obviously how the break-evens, how it all changes, that's an easy indication to where, why is one operator outperforming the other? Is it geology? Is it completion design? Is it some sort of trend? So it's a very powerful, because as you were looking into, each little part of this, I guess this visual right here, it tells a different story. And it tells a different story through time, which once again is really important. Case 2, this was acreage grading. So how should leasing opportunities be evaluated even across basins? So leasing, that's important, because before you can even drill, number one is you have to have rights to the land, and that it all starts with the lease. So there's the acreage grading metrics, and it's historical and it's relative, and it measures it by play. There's the whole making the quantitative comparisons, it makes it, they're difficult, and especially across opportunities. So when you have to make a decision, and you have to make a decision quickly, but you're trying to understand, okay, so even if, if you were going to invest in a particular area, which one is more productive? The acreage matters, because the land is on top, but then the geology sits below. So it's very important. So acreage grading at scale. So you can see this was weighted break-evens by play section. And then you can see the break-even by play section, and also then by operator. And then even then down to the immediately see the average weighted break-even for the whole state. And you can see it takes it down to the cost level. So from an investment perspective, and then from a risk perspective, or if you're thinking about partnering, just understanding, their assets and the profitability of their assets, it's a big deal. So now with this one, this is sort of keep continuing to go into it. You can continue to drill down. So notice now that you can actually see the wells and the sections, and then the break-evens by play section, and then also by operator. And so this was important because, with this particular proof of concept, we have our own algorithms that we basically gave over to OmniSci. They were able to recreate them and then embed them. And so this actually gives the customer control, which, in our current environment, in our current products, it's, we can run the model and you can apply it to specific areas. But then once you embed it within OmniSci and you bring all the data together, then from a user point of view, you can start applying the model towards really anywhere that you want. And it's calculating interactively on the fly. And then this was using the parameters in OmniSci to help you drive your analysis. So this is the one where, you're just looking at the break even by operator and by play section. But then with OmniSci, you can actually get into the parameters, and then you can create your own insights into your own data by changing up the variables. So this is what I mentioned before. So you going in and being able to actually make your own selections. That's great. Everyone can love what we do, but then a lot of times they want to be able to run their own what ifs. So having the ability to go in, change your variables, change the parameters, and then rerun, it's very powerful. Now, spatial temporal, understanding how your data changes across time. This is a really big deal, because for any predictive analytics, you can't accurately predict unless you understand the past. And so that's where the historical values, that's where it's a really big deal. So, this is how for this particular example, or this POC, you're just watching how, just your well factors change over time. And it's easily going through, this is over 500 million records, because not only is it taking it well by well, but it's taking it by data point within the well. And there's a multitude of data points. So when you think of production, that's something that happens every month, but then some of these wells that are producing for, 10, 20, 30, 40, 50 years, it all stacks through time. So then you can also tell when it goes up or when it goes down, what's contributing to those different trends. And then that's what's great about OmniSci, of course, is that then you can bring in other data to understand, what are there any other, is there anything else that's affecting performance that may be something that, maybe not something that's obvious, but if you wanted to bring in, I don't know, weather, or if you wanted to bring in geopolitics, those are other possible performance indicators that impact and that vary across time. And then this is rapidly compare operators. So, that's one of the questions. It's, how, from our customers, it's, how do I compare to my neighbor? Or if you were evaluating, different operators and who's more productive, or, who's, from a drilling perspective, who drills better wells. This is just an easy way to benchmark. So this one was average operator by break even. You have the wells by break even. There are historical break even factors with the decline rates. Then also taking into account it's their wells within the 12-month post-peak declines by peak productivity, and then your expected EURs. So this normally, by bringing all this data together, this could take forever because it's bringing in all of these different factors, whether it's on spreadsheets or some other BI tool, but having the ability to load everything into OmniSci and interact with it pretty much instantaneously, and even get down to those granular levels, or at a well by well level. This was exciting. A new standard for benchmarking. Okay, so this one is break-even changes by TBD versus lateral length. So especially when it comes to production prediction and when it comes to completion design, you have a multitude of variables. And so when you're trying to understand what is actually impacting production, is it, your total vertical depth versus the lateral length? Is it your, total vertical depth, total vertical depth versus lateral length by break even? Same thing by decline. And then when you start coming into then getting a little bit deeper, then you have your frac stages, and then you have your number of frac stages, but then your frac stages and your fluid volumes and your EURs. So being able then to understand and analyze this through time by reservoir and by operator, this is what you're always striving to achieve. But with OmniSci, you can do it all together. And then you can understand the impact and then the dynamics of how the different variables, how they play against each other all together. And this was the temporal evaluation, the rise of fracturing. So this was, where you can see the whole, as you're measuring, as you're hover overing it, you actually have all the details of the, of the frac stages and the fluid volumes and the EURs. And this is, it's really a perspective, well, I guess it's keeping in perspective the relevant commodity price environment, like the whole WTI, and it affects on well productivity and the EUR performance. So especially when you start getting into investment and finance, this is a really big deal because, it tells you a lot. So from a risk perspective, being able to do this with all these different data points together, it's an easy way to manage to measure risk. Now, this is a great one for IHS Markit. This gives us, this is our global perspective here. So this was high performance supports cross-national comparisons. So this was, you have different operators by different criteria, operators by different geography, where you can see, and then we sort of flag them all out. You have the company names and then the unique number of awards. So this is an international data set, but then you can see how it's allowing you to then compare, whether it's a well in Oklahoma or somewhere in Africa, so it's having that ability to compare basins globally, because a lot of times from a completion perspective, you may be on two different sides of the world, but then for analytics, there are similar reservoir, geological properties that you can actually compare for benchmarking and just other types of analysis.
I just throw in there, again, that's a great overview, but again, the key there is really the different types and massive amounts of data and the need to get to them quickly and analyze them fast. That last slide showing the global data, or a big portion of it that comes from IHS Markit, is interesting to me because it's never really been easy to work with that much data in a global perspective, and then not just see it, of course, but start to run some analyses against it on why a particular wells in a particular field acted a certain way versus in another basin. So anyway, I think that whole concept of ease of access and speed of visualization analysis, really excited about the different things that Ali talked through.
Yeah, no, definitely. I mean, the whole speed of thought and interactive analytics, it's game changing. It's impressive when you start looking at everything it's doing and how long it would take you to do that without something like this. It's very impressive. Yeah,
and going back to that concept too that I touched on earlier, that we get very focused within a particular domain, and let's talk about, let's suspect it's upstream, and we're talking about the shale plays and what we need to do, and the density of that data, and where is one well bore versus another, and more importantly, why does one well bore act differently than another one? But when you start to pull up and go further and further away and start to think about asking questions that might, they might pull on the number of Toyotas that were made this year, and the number of chickens that were born in the agricultural world, that goes to how much feed do they need, that goes to how much fertilizer, and you take, and I'm just kind of throwing a few of these around, but when you start to think about these different data sources and that they ultimately all come back or tie in to things like, let's just say, exploration and hydrocarbon production, and you start to think, I could just start to query that breadth of data, I think that's really where it gets very exciting. And I think in our space in upstream right now, we need that kind of step change in managing and dealing with data that we really haven't necessarily had before. It's pretty important for the industry right now.
Very good. And David, thank you for the introduction and also the insight. And Ali, thank you for going through the use cases in the business that you've started the journey with us as well. By way of introduction, my name is Chung, and I am part of the journey that IHS started with us months ago in this area to use OmniSci as a platform to provide the insights, the business advantages that Ali has been going through using our platform to be able to represent that data in a very new and innovative way for them to do their business and represent it for their customers. That being said, I kind of want to take this time and opportunity to transition into some of the key and core features that OmniSci has brought to the market itself there. And as you can see in this particular slide there, OmniSci has presence and stretches across many different types of enterprise and telco companies, that basically organizations in the market today that have very large sets of data that they need to render and they need to process and do analytics on top of. And that's kind of where our sweet spot is. So that being said, as you can see, there's a number of different use cases typically customers get involved in to be able to do today in their current environment. But what they don't realize is that having the ability to take data sets that's already been done or aggregated in certain type of use cases that you see out there, and a lot of these use cases I'm sure you already have been doing or in the process of implementing already, and building another dimension out of that. What I mean by that is, for example, what if you're taking churn to look at your customers, looking at pricing elasticity due to churn, or even looking at things that you've never been able to combine together previously, like taking social media analytics, looking at what people are saying about your company, and on top of doing things like network analytics on top of that as well. So, for example, the power of OmniSci basically allows you to bring different types of data very quickly, disparate or not, into a single platform and be able to allow you to overlay them through a single point of common denominator, like a time series, for example, and then look at the effect of that across time or across a particular location, and be able to identify what that uniqueness and be able to come up with a new dimension of your use case and your analytics in general. So that's really the value that we bring. And to do this, to do it very quickly and very easily, is also the core vision that we have for all our customers as well. So from the insight standpoint, OmniSci consists of several key important components. Number one, we understand that it is very important from an analytical standpoint to get the data into a platform to start the analysis right away. Right? So that being said, we have a very strong and very powerful ingestion capability, where we're talking about being able to ingest millions of records depending on how wide they are, to be able to get it real time into our system and our platform so that you could immediately get the near real time results that you want. Number two, the data that's stored in OmniSci is based on a columnar database, which means that right off the bat, you have the ability and ease of use to be able to query the data in your structured format that you are familiar with right from the start. And number three, which is really the secret sauce behind and why NVIDIA is so important as a partnership to us as well, is because we leverage their GPU technology and optimize our product to be able to run in the best way and in the fastest way possible with their technology together, and hence giving you the results that you need from querying billions of rows, merging them, aggregating them, joining them together, and it happens in seconds, or less than that sometimes for that matter, and be able to provide that power of the analytics, power of doing machine learning and AI modeling right on our database and right on our platform itself there. And that's because of NVIDIA's technology merged with our software platform out there. And finally, what brings it all together is the ability to visualize all that. Our protocol is Immerse, which comes with the product itself, to be able to join these tables together, and what Ali was showing previously and how we were able to represent their data very easily, very interactively for the customers and for the users to use from that standpoint. Now, from an example standpoint, we actually have a number of organizations globally that have been using our product, and this product has been well proven on its tracks as well. As you can see, some of our telco customers use quite a bit of our platform to be able to analyze their use cases that they brought in. And for example, some of our telcos have over 36 billion rows to be able to represent that within our product. We also have a federal division with our organization to be able to service government agencies across the world, and some of them have over 100 billion records using our product to be able to do their analytics specifically as well. And with our close partnership and friend, NVIDIA also uses our product in general to be able to do their gaming analytics, and they do also have a number of a massive amount of data used in our product from that standpoint. So let me just take a couple more minutes to kind of talk through a little bit about several use cases that we have outside of other industries that we work with. In specifically, for example, in telco, very much a heavily used platform for some of our telco customers, and a lot of that's because their data, again, has to do with the amount of volume that they have to be able to combine and join and quickly find a needle in the haystack to find, for example, detecting fraud anomalies in the network, for example, and looking at churn and making sure that they have the opportunity to find how they could identify where their valued customers are and preserve that so they don't move to another operator or provider because of quality issues around that. Another great example that our telco customers use this is actually to look at 5G deployment planning and capacity rollout for 5G technology itself there. Being able to draw and identify location, geospatial information very rapidly to basically map out is the key element where other applications, either they do it too slow or just cannot even go down the path to draw the actual visualization for them to identify the capacity and planning for them. So that's one thing that our product does very well from that standpoint. Another great industry that uses our product and fits very nicely into their model is the utility business. And they basically take our data, for example, and look at LiDAR data to be able to identify things like making sure that they could optimize where the placement of electricity poles, for example, and how that may impact from fires. Obviously, there's been a lot of that happening recently. So taking this technology and predicting vegetation growth information, for example, and then be able to be proactive to sending a team out there to cutting down the trees that's close to power lines, etc. out there, looking at leakage, customer information about how they use it, and come up with better modeling and pricing modeling for the customer base out there as well. Public sector is very big for us in terms of government agencies using our product. Very much they provide analytics around tracking of objects, and I'll leave it as there from that standpoint, and also from the ability to make sure that they could visualize and interact to find that movement of objects as well from that. So that's one thing that we have a very close relationship to be able to help agencies across the world to provide that type of technology and use case to them. And so that's the end of my presentation. Thank you.
Okay, thank you very much. We just ended with session 3.